So quick quiz, 1 to 10 in your margin for me, and quickly just answer the following 10 questions. Pause the slide now. Thank you. So my answers: Newton's first law, an object stays at rest and in the same direction. You can read, unless it's acted on by an unbalanced force. State the equation for force, which for Newton's first law, force equals mass times acceleration. And what type of energy is dissipated due to friction? Thermal energy. Heat energy is fine. Thermal energy is a better answer. A boy walks from school reception 500 metres to the dining hall and returns to the spot. What is his distance travelled? 500 metres. His displacement would be 0, just as a point. True or false? Vector has magnitude only. It's false because it has both direction and magnitude. Newton's third law, every action there is equal and opposite reaction. And then number 7 is all about biology revision. So word equation for aerobic respiration: glucose plus oxygen, carbon dioxide plus water. Tug of war for war teams in pulling in opposite directions. Team A are pulling in force 1500 newtons to the left. Team B are pulling 2050 to the right. What is the resultant force? Obviously 2050 minus 1500 equals 550 to the newtons to the right. How can you describe the centre of mass? The centre of mass is of an object where all the mass can be thought to be concentrated or acting through. If the shape has got a dodgy shape, it doesn't actually have to be on the shape. Just be aware of that. If you've got like a kidney bean shaped object, it can actually be off of the shape. Random, I know. Last question, question 10, chemistry revision. During electrolysis of a solution of sodium chloride, which anode will the chlorine ions go to? Chlorine ions are negative, so they'll be attracted to the positive cathode. Learning recap. What is a resultant force? Think about this. So the resultant force is a single force that has the same effect as all forces acting on the object. Calculating the resultant force and direction of force action of each using a free body diagram. So this is where the arrows indicate both the magnitude and the direction. Now, ideally, these are best drawn to scale, but you can just indicate it with different size arrows. So have a go at doing these ones for me. So here's the answers. 5 newtons up or north. If you're not that au fait with north, south, east, west, okay, it's quite happy to say up or down, because the person marking your exams, will have a range of acceptable answers. Don't try and be fancier if you're not confident. Use basic English and you will get the marks. Second one, so we've got 1600 newtons acting 16 newtons acting in to the right, and we've got 9 newtons acting to the left. So 16 take away 9 equals 7 newtons. Now, the next one, this is quite a common one, and they really do want to know whether you can cancel out the forces. So, first of all, it's a bit of a trick. You've got 9 newtons acting to the left, 9 newtons acting to the right, but you've got 7 newtons acting down and 3 newtons acting up. Obviously, the left and right forces cancel each other out because they're equal and opposite. However, there is a excess of 4 newtons acting downwards. What are the 2 possible scenarios where motion when the resultant force on an object is 0? Now, we've talked about this before. A common misconception is that when the resultant force is 0, that people think, well, it must be stationary. However, it also can continue at the same speed and direction of direction that it's currently travelling in, assuming there's no other forces. Okay, so determining the resultant force when it's not in a straight line is not as simple. So we need to use something called a parallelogram of force. Now, this is essentially higher paper material. However, it does touch on it on the foundation tier, and those of you aiming for that 5 really should have a crack at this. I think everybody should have a crack at this just because it's fun and we've got nothing else to do today. So we can use this parallelogram of forces. Now I'm just going to recap maths, and apologies for you, those of you who are math geniuses, but a parallelogram is where the opposite sides are parallel to each other. That means if I continue those lines for infinity, they would never touch. Okay, so we are going to need a sharp pencil, ruler and a protractor for this activity. If you haven't, just make notes as you go, but you're going to struggle to do the workings without. Okay, so you find the resultant force, and when two forces are working in different directions. Here's a lovely parallelogram, and it's my four-sided straight. It's a quadrilateral. It has pairs of parallel sides, and as I've said, we can indicate those parallel sides by, if we was extending them for infinity, they would never touch. The sides of the parallelogram are of equal length, so that's something they're expecting you to pull through from maths. Remember, 40% of the physics paper is pure maths. So if we can get that maths down and you can get that maths under your belt, you're actually in a really good position to get your target grade or above. The opposite sides are also equal length, because if they weren't equal length, then the shape wouldn't be a parallelogram. We can indicate which sides are equal and opposite using the little arrow annotation. So on the ones that are horizontal, I've got one single arrow, and on the verticals, I have got a double arrow. So you're probably looking at this game, well, what the hell? So if you imagine that we were trying to pull a car, they always seem to use boats, and I think that's because there's less friction in water. However, pulling a car is the same. If you try and pull a car and you imagine you and your mate have got a rope from the centre of the front of the car and you're pulling it forward, okay, because you're not directly in front of the car, you're pulling it different directions. And if your friend is much stronger than you, or you're much more stronger than your friend, it will actually have a different force and the car may not go in a straight line. What we're going to do is calculate the resultant force, and to do this we need to know F3, which is our resultant force, is equal to F1 plus F2. So we've got a large container ship, again back on the boats, tugboats. These are little boats that move big boats into position, and we're going to work out the resultant force. So you will need these steps. You'll need to remember them because this is what you're going to need to be able to do in an exam. First of all, remember that it's a scale diagram. So we've got 600 newtons, and 3,500 newtons. Therefore, tug 1's line will be 6 centimetres, whereas tug 2 will be 3.5. 1 centimetre will equal 1,000 newtons. That's my scale. Step 2, copy out one force and draw the length to scale. Step 3, use your protractor to measure the angle. And then we're going to draw out the next force from this angle. Now, as a parallelogram, opposite corners are equal angles. So we'll have 55 degrees at opposite ends, but also as it is a quadrilateral shape, we'll remember that all the internal angles must add up to 360. So there's a bit of working out for you. Calculate the angle of the next size line. So 180 minus 55 equals 125. Draw the next force line from this angle to scale. So again, it's 6 centimetres because my first line to tug 1 is 6 centimetres. Draw the remaining line in the parallelogram. Just double check your angles to check it's correct. Draw a line from the point of the original angle to the opposite corner and measure the line accurately. This is the resultant force. So the direction of force is taken from the angle between the resultant force line and the largest force. There we are. And we can measure that again with my ruler, and that gives me a resultant force of 7.9 centimetres. Can you pause the slide? Can you write down these steps? Because this is what you're going to need to do for the next activity. So if I'd done it on graph paper, okay, what we can see is it's 8.4 centimetres, which is more accurate, and it also gives me 20 degrees to 6,000 newtons, okay? Now, have a go at doing this question. Think about it. What is the examiner asking you to do? Right, that's it. Basically, they want you to draw a parallelogram of forces and using a scaled vector diagram. So this is what it looks like, okay? Again, I've got my scale of 1,000 newtons equaling 1 centimetre. And now we've drawn it accurately, we can measure it, which gives me 13.3, okay? And it's 23 degrees to 7.2, okay? Or 13,300 newtons at 23 degrees. Explain why the drag force has a drag force on this ship. What does the examiner want you to do? Think about the first law, okay? The drag forces on the boat are equal in magnitude and in the opposite direction. Therefore, according to Newton's first law of motion, the boat will move at constant velocity and speed and direction. So, have a go at doing these. Force of 3 newtons and a force of 4 newtons acts on a point. Determine the magnitude and direction of the resultant force if the angle between their lines is 90 degrees, 60 degrees, and 45 degrees. Pause the slide, have a go at these. Here's my answers. You might have drawn them out, but these are the ones that we've done, okay? You'll notice that the line, the angle is always between the largest force and the parallelogram line, not the smallest. That's the consistent rule that we're applying there. So here's the key points from today's lesson. There is an activity on SAM Learning. Please can you go to SAM Learning and attempt today's activity. Take care. Bye.